Okay, in this video we are going to learn how to minimize the sum of two positive numbers whose product is given. So say that two positive numbers have a product of 81. Find the two numbers so that their sum is a minimum. So how do we solve the problem using the tools we have learned in differential calculus? So first, let us denote the sum S, or rather denote the sum by S, and the two positive numbers by, say, variables x and y. So that means S in terms of x and y is simply, obviously, x plus y. Now that is what we want to minimize. Now we are given that the product of the two numbers x and y is 81. So let's denote the product by P. And in terms of x and y, that would be xy. And that is set equal to 81. Now, next we solve for y in that equation, for P. We divide this equation both sides by x, giving us y equal to 81 over x. Then we substitute that into the formula for the sum S here. And so we get S in terms of x now as x plus 81 over x. So again, note that S is now a function of x alone. So to get the x value that will minimize the function S of x, we get, or rather we differentiate S with respect to x and equate that to 0. Differentiating S prime is equal to, okay, the derivative of x, differentiate x, and we know that is 1. Then we differentiate the next term. Now we can quickly get the derivative of that by writing it in power form. So 81 over x is 81 x to the negative 1. So we bring down negative 1, getting negative 81. And then we take 1 from the exponent, so we get negative 2. And just rewrite it as 81 over x squared. So we get s prime equals 1 minus 81 over x squared. We equate that to 0. And solve for x. So, solving, we simply transpose this term to the other side. Then we will just sort of switch the sides. Get the following. So 1 minus 81 over x squared equals 0. Transposition gives 81 over x squared equals 1. Now, by cross multiplication, if we look at this one, the right hand side, if we think of it as 1 over 1, then we can simply cross multiply to get the equivalent equation x squared. Okay, and then this one. So we get x squared equals 81. Now since x and y are positive numbers, so we get only one solution for x, one critical value, x equals 9. So that means this is the x value that will minimize the function s of x. So next we get the other number y, and that can easily be found by plugging x equals 9 into the formula here. So if we replace x by 9, we get y equals 9. So let's just write those again. So we got from this equation x equals 9, and from this one we get y equals 9. So these two are the numbers that will give us the minimum sum. And it should be clear that the minimum sum is 18, and that is obtained simply by adding the two numbers 9 and 9. So we write minimum sum s as 18. Again, you just add the two values, 9 and 9. X value is 9, y value is 9, the sum of the two, 9 plus 9, so the minimum sum is 18. Now, before we end this video, let us just verify that indeed the sum 18 is the minimum sum, of course it could also be the maximum sum. But how do we tell if it gives a maximum sum or a minimum sum? So we use the second derivative test. So let us compute the second derivative. We got the first derivative ready. S prime equal to 1 minus 81 over x squared. We differentiate that again to get the second derivative. So we have S double prime equals. So we differentiate the first term 1. The derivative of 1 is, of course, it's a constant, so the derivative is 0. So we won't write that down. And then we differentiate negative 81 over x squared. And again, we can think of that as negative 81x to the negative 2. We bring down negative 2. So we multiply that to negative 81. We get positive 162. And then we subtract 1 from the exponent. So we have x to the negative 3 as, okay, 162x to the negative 3 as the derivative, which we will write as 162 over x cubed. Now, to know if the critical value x equals 9 gives a maximum sum or a minimum sum, we simply plug that value into the second derivative. So let's evaluate S double prime at the critical value 9. And observe that we get a positive result. And recall that function with only one critical value and whose second derivative is positive would mean that the graph is concave upwards. Sorry for that. So indeed we get a minimum value for the function S. So let's just conclude by writing down our final answers. So the two numbers that would minimize the sum are 9 and 9. And we just write or say that the minimum sum, if asked, okay, the minimum sum is 18. And that's it.